first of all, my name is Abdul Rauf, and in this video, we will talk about stake and queue. So, first of all, what is a stake? So, a stake is a last in, first out LIFO data structure, which means the last element we in the list will be the first one to be out. So now let's see some simple example or graph of this. There you can see some elements in the graph like one, 2, 3. So I'm waiting 1, then 2, then 3. This is known as this heading system is known as the pushing. Where I push a element above the previous one. So here you can see 1, I push, and then 2 push, and then 3 pushing. After pushing the 3 element, when I pop the most recent one, the last one. The 3 is the last one. For example, the last in first out. So the 3 is the last we in the stake will be the first one to be pop out. This is known as a stake. Now let's see the real world application, like why we use stake or why we learn it. So for example, when you check your email, the recent one will be top and the old one will be at the bottom. So the last email we get, like the recent ones, will be the first one to be out, shown. This is known as a stake application in real world life. Okay, now let's see some code of this. So here you can see I'm only showing you main part for now. So you can see I create a stake. That stake is a class which I use the stake which stake function where which I already mentioned in the previous video too. So here you can see first I'm pushing one element, then pushing two, then pushing three, and then I'm printing them. So you can see three, two, one, and null. So null is the last. Okay, I already tell you that. So you can see I'm now popping. The popping element will pop the three element. Now let's see the three was the last element we in will be the first one to be popped out. And then I'm generating again. And you can see now the three is removed, and now we can see two, one, and none. So you can see I'm also using the linked list here to implement this. So now let's see a code step by step so you can understand basically. So first I create a stake. So I first create the boilerplate code like include IO stream for input output and for using namespace st for the string properties. Now after that you can see I'm creating a struct again. So this is the node struct where I already created int data and node star text. Now you can see this code I already tell you in the previous video where we were creating a linked list. Okay. So now here is the new thing is this constructor. The constructor will only initialize the value. Like we were first we were assigning in the previous video, the previous code like a linked list. We were assigning the constructor. Not we are not adding the constructor, but we are adding the value ourselves. But that is very complicated. Like when you want to add the new values, you have to do again and again and again, and it will get more complex. That's why I'm using constructor. So the node int v. So the int v will be the value that we assign in the class, and then the data v. So the value will be assigned to the data, and the next will be the ptr. So we do not have to do it again and again in the code. So we set to one in here. So this will initialize the all the structure we create in the code. Okay. So that's why constructor are very useful. So now I can see the simple code here is like this node where I get in data and node the next or point to the next point. Okay. So after that now let's see some other code like the struct stake. So stake I'm creating a class of stake. I'm using struct. I'm not using class because struct is more easy than class. Now I can see I am pointing to the head now, so the head will be my pointer, and then I am mistaking the and this is also a stake. This is also the constructor, so I am heading the head to be the null ptr. So I'm initializing the head for now to be the null ptr in the beginning. Now after that I am adding function like push function. So in push function I will add a new node to the top of the stack. Okay. So now first you create a function like void push and then assign the value like int v. Then you create a new node, then you assign it n, then you create a new dot where you assign the v value. So v value will be assigned to this constructor now, that is this v study. So here you can see that this v value will go to this constructor and assigned to the data variable, and the next will be null ptr. So this is how the constructor works. So after that you can see I am assigning the next if we have the next pointer in the stack will go to the next head. So the head will be empty, and then we can assign the head to be the n. So uh, the new element will be top of the stack. This is how it works. Okay. So now after that let's see the pop method. So in the pop method we are first asking like if head is equal to null. If head is equal to null, then we know the stack is empty. Okay. So we go. If not, then we can see node start or t. So we assign a template node, so we do not manipulate the head directly, and then we are assigning the head to the next pointer, and then deleting the temporary, so the three will be deleted. So this is very simple. I know it may sound very complex to you for now, but you can understand by practicing and thinking about it. Okay. So after that, now let's see the last one, which is we have print. In the print, I print all the elements. So first I assign the function, I create the function, then I assign the node temporary again, and then I am using a while loop. Asking for like temporary is not equal to null. If not null, then it will print data, and then this is a string I am showing you. For the example, if you do it or not, it will also work. But I am showing you to you so you can understand better. Like this is the arrow to the next pointer, and then I am assigning t to that next. If I don't do that, then the loop will be go infinite and then print the same value again and again, because we are not changing the temporary value. It says I am changing the temporary value to the next pointer, and then I am, for example, in the last of the list, when the head is equal to the temporary is equal to null ptr, I was saying CODT. I'm printing that this is the null ptr. Okay. So yeah, this is the print function. So yeah, these are the three functions I implemented in the stack application, and you can see this was the final result. This was the final result. Now you can see I'm adding and pushing. I know it may sound a very complex code, but it is very easy. Trust me. You can see more nightmare code in the future. I hope you will not. Okay, so now after that, let's see the queue. So queue is a first in, first out before data structure, which means the first element we in will be the first one to be out. So it is very different from the queue or from state. So here is the graph or simple example of queue. So here you can see. Sorry, I didn't change the heading here. It will be queue, not list. Okay. So here you can see I add the element here. The first element is 1, second is 2, third is 3. So it is this is not the increase. The same like it is same like mistake. We are adding in the last or the top of the element, the new element. But when we are removing, we are not removing from the first, but we are removing from the last, like the one. So this is not the NQ when we adding, and the DQ when we removing. This is not the Q. So now let's see some code of this. So you can see first I'm entering 1, then I'm entering 2, then I'm entering 3, and then I'm printing them. So you can see 1, 2, 3, repeat null. After that I am printing, then I am dequeuing. For example, the 1 will be removed. Now you can see 2, 3. This is known as a simple addition, like line. When we assign some line, we the first one in the list, first one in the line will be the first one to be served. Last one in the line will be last one to be served. For a real world application, for example, the forms we say the forms or like some reports or like this, the the first one we give priority will be the first one that was sent. So that's why we use FIFO there. So now I can see the code. The node is like same. The node is same like the mistake. So I am creating a stack node where I am editing the data node start to the next pointer, point to the next node, and then I am constructing like node in V. The V will be data V, and the next will be null T. So this is the concept. So after that, I am creating a struct queue where I am assigning the head to the pointing to the head now, and then I am assigning the point to the constructor like null ptr. The head will be the null ptr in the start. So after that, you can see I am adding the queue function where I am adding the int v value in the node n new node v. So this is not the nq. You can see the nq is like same as the uq. Uh, where NQ is like NQ is same like in the stack we see we add the element first, but in this we are adding the element in the last. So that's why if the for example if the head is null ptr, so if the head has no value for now, then we can assign the n value, the node value. But if the head is not empty, then we have to look over through the last node. So we can use else node is equal to, so we are assigning the temporary to a temporary node for now, so we cannot manipulate the head directly. And then we are using a while loop, so we go till next ptr and see check we go to the next ptr in the temporary node and see if it is not null. If it is not null, then we go again and again. So we go to the last element. So if we go to the last element, we go out from the loop, and then we see the next variable and assign it to the end. So the last element in the queue will be added here. Okay. So this is is how we can add the element in the last of the queue. Okay, so after that we can add the queue function. The queue function is same like the pop function. We didn't change anything from there. So you can see first if head is equal to null bit, then we can say queue is empty. If not, then we assign the temporary node, and then we assign the head the next pointer, and the now the temporary variable is not carried to anyone, and I can use this. So yeah, this is how the queue work, and how this is how the queue work, and this is the code. Now finally the print function is same like the in the sticks. So the print function didn't change much. So yeah, after that you can see we get this result. So yeah, this is the queue, and this is the queue, and the previous one was a stack. So I know this was a little bit complex, but I hope you understand a little bit. I can provide you some code in the report too, so you can check out too, and try it yourself. So yeah, this was all. Thank you for watching. In the next video I will talk about trees and binary trees. Bye and take care.